can assist you or tutor you more. If you have more questions, just email me. Stiff leg derrick used on ships is supported by a ball and socket joint at D and two cables BA and BC. The cables are attached to a smooth collar rings at B, which allows the rotation of the derrick about the Z-axis. If the derrick supports a crate having a mass of 200 kg, determine the tension in the cables and the XYZ components of reaction at D. So I already drew the free body diagram, and this is another one of those problems where you need moments in 3D to solve the problem. And actually this one is much harder, I think, mathematically, comparing with the question, the previous question and question 66. So anyway, as we always do, we're trying to find the tension that's going to a different direction into its Cartesian form. So TB equals the magnitude of, I'm sorry, this is TA. It's TA right here. So over here, I should write TA as well, right? TA is equal to the unit vector of the rope. So let's see, for X direction it moved to the front by 2, so that's 2 over here, and it moved to the Y direction by -3, so it's -3 over here, and for Y direction it moved down by 6 meters, so it's -6. 36 plus 9, 45, plus 4, 49 divided by the square root of that gives you 7. So that's TA, and TC, my bad, TC over here should gives you the magnitude of TC times the components. X direction it went backwards by -6. Y direction it went backwards by -3, and it went down by -6, which is similar to C. 36, 36, 72 plus 9, 90, 81, 9. Right, all this are equals to 9. Okay, we can simplify this, I suppose. This is -2 over 3, 1, -1 over 3, and -2 over 3. Right, and get rid of that little confusing dot over there. Okay, TC. Right, and then we use the some of the moments to, set some equations, some components into some other unknowns into like equals to a certain amounts. So once you find one, you can find the others, right? So some of the moments in the some of the forces in the X direction, that should be TA, magnitude of TA times 2 over 7 minus plus, we're just going to write everything in its original form, times TC, right? Times TC, this is X direction, and also the reaction force at D, so plus dx, right? This thing should give you 0, and YF, all the sum of the forces in the Y direction, TA and TB, they're all very negative. So it's D, so dy must be positive in this sense, right? Minus, what is this? 3 over 7 TA, and minus 1 over 3 TC, right? And all of this gives you 0. And finally, the sum of the forces in the z direction. So all of this is negative, so dz must be positive, right? So minus 6 over 7 ta minus 2 over 3 tc, and minus the weight of this load, which if you times everything together, it should give you 1,962, I believe. Yeah, and all of that gives you 0. Okay, so now we have some of the forces. There are too many unknowns into analytic equations. We can't really solve it. There are 3 equations with 1, 2, 3, 4, 5 unknowns, so it's impossible to solve them with just these 3 equations. So we need to write more, right? So from now on, we can use the sum of the moments methods. So this is equal to 0 sum of the moments at d, because this get rid of the most amount of unknowns at the same time. So it's rdb cross, sorry, that looks like an x, cross the tension, so ta tc plus wait, not the magnitude, just tc plus tb, right? M plus the r d to the, what do we call these things? Let's just call here the weight, right? So dw cross, well, this force over here, which is the weight of the load, which is 261 in the k direction. Okay, and this should give you the sum of the moments at d, right? Here we go. This is where the fun begins, using tons of cross products and matrices. We can first simplify this part of the equation. This is really simple because this only have 1, so I, j, and k, right? This moved up into the x direction by 1, right? Moved from here to here. That's 1. Moved in the y direction by 4, and the x direction by 7, z direction by 7.5. And since the force is going into k, into the z direction, this is 1962 into the negative direction. And if you solve this matrix, 1 minus, cover this, 4 times this, so 4 times negative 162, right, over here. This is the I direction, right, this minus this, 0 times 7.5, 7.5 equals 0. Cover this, 1, so this is negative 1962. This is the J direction, the I direction, and then for K, 0, 0, which is 0 for K, which makes sense, right? Because this thing can make the X rotation and the Y rotation, but it cannot make a Z rotation, right? That would be very crazy. So we have the components over here, and now we can use the components over here to solve for our dB, right? RdB, which is yep, over here. If you, right, so the I, J, and K, right? Which is basically, okay, so 0, 0, 6, that's the rod, right? From here to here, 0, 0, 6, right? And for this thing, TC plus TB, which is basically the sum of the forces minus the dx minus dy minus dz, and then minus this thing over here. So we're not going to write the whole entire equation down. We're just going to say the sum of the forces, sum of the Fx forces prime, because and this thing over here equals this minus the dx, right? Does that make sense? So it's, you know, a simple acronym almost, right? Y prime and sum of the forces in z prime. We'll write everything down over here. Okay. So solving this matrix over here, cover this as this minus this equals this times this. So it's negative 6 times sum of the y forces, which is this over here, get rid of the dy, right? Which is that negative 3 over 7 times ta minus, what is that, 1 over 3 tc, the whole thing, right? And this is the I direction, right? Eventually we have to submerge these two together, but we'll keep this for now. And then k, for j directions, we cover this as 0 times equals 0, minus this, so minus 6. So fx, right? Get rid of the dx, which is negative. Wait, sorry, not negative, just 2 over 7 times ta minus, because plus and negative equals minus, minus 2 over 3 times tc, right? And this is the k direction. And for k, you cover this, 0 times 0 equals 0, so there's no k and no moments in the, sorry, this is, what? This is j. This is j direction, and there's no k and no k directions, right? Which is super nice because these two combine each other perfectly. So now here we go. We have 0. We add these things together, right? So negative 6 times negative 3 over 7 ta minus 1 over 3 tc minus 4 times 1962, right? Or we can just set this, move this to the right side, which is set that equal to this, set, you know, equal to that. And then negative 6 times 2 over 7 ta, right, minus 2 over 3 tc. That should give you well, minus 1962. We can move that to the right side of the equation. It gives you 1662, which is simpler. And then we divide it by 6 by both sides, and then so divided by 6. So this thing and this as well, and get rid of this, right? What's 101,962 times 4 divided by negative 6? That would give you that should give you negative 1308, and this 1962 divided by negative 6, that should give you 323, right? So here's an equation that you can use. So instead of using substitutions, you can use your calculator. If you have a TI-84 plus, you can use the 2x2 matrix, right? So it would be just become an equation of negative 3, 7. This is the first matrix. Let's just call it, we'll just say TA, right? Minus 3, and this is TC. This is your second matrix, and this is 08, and then here is 2 over 7 TA minus minus 2 over 3 TC. This gives you negative 3, 2, and 7, right? And put this into your calculator. If you don't know how to use it, I'll run through it with you real quick. Click second matrix and then move it to the edit, and then click on one of it that's empty. Right? And so there it will be a 1 times, originally it would be 1 times 1, so it changed into 2 times 3, right? Click enter, and then just type the coefficient in front of the numbers. So negative 3 divided by 7 for the first one, the 1, comma 1, and the second one should be negative 1 over 3. That should be for 1 column 2, and then this is 1 column 3. Type in your number, negative 1,308, right? Move it to the second column, 2 over 7. Second is negative 2 over 3, and negative 3 to 7, right? And then once you type everything in, hit second mode, that's quit, and then hit second x to the power of negative 1, that gives you the matrix column. Go to math, and then move upward. You will see B, R, R, E, F. Hit that, hit enter once you move that to the column, and then hit second x to the power of negative 1. Find your matrix. Mine is the fourth, so move on to the fourth. Yours probably the first or X number. Hit enter, and then finish the bracket, and it should give you the two numbers. So 1, 0, so 1 at your position should be the TA. So your TA, your calculator should give you something like this, right? 2, 2, 8, and 1, 3, 4, 8, right? Once you typed in. Since this position was your TA value, this position was your TC value, so this is TA is 1 TA times 2002, so TA should give you 2002, and TC should give you 1,348 newtons, right? And after that, we can substitute all of these numbers into the number up here to find dx, dy, and dz. Once you do that, I'm not going to do it. Once you put everything in and substitute, well, since we already have it, we might as well just write it on top. So TB, we already found what TB is. TB is, I'm sorry, TA. TA should give you 2002, so 2.00 kilonewtons, and TC, sorry, should give you 1348, so 13 should give you 1.35 kilonewtons. And yeah, plug all of these two numbers in here, right? TA, TC give you TX, so TX in the end should give you 327 newtons. Get rid of that, that's not a decimal place. And dy, if you plug these two numbers in, dy should give you 1.31 kilonewtons, right? The 4 digits, I think it was 1,307 newtons. And dz, put everything in here, minus the 1,962. dz should give you 4,576, so 4.58 kilonewtons. And here we have it for this question right here. This is a super long question. I don't think you will get in your test, but if you do, do use your calculator because the substitution can really mess you up. I tried to do this and it took me an hour. Yeah, hopefully, let's finger cross that your professor won't put this kind of a question on the exam, because yeah, this took so long. Anyway, hopefully this video was helpful and would support you on your revision for the test. I mean, use this question as your revision, right? Because once you can do this, you can do all of the problem in the second set of chapter 5, equilibrium 3D. Anyway, so yeah, good luck, and I'll see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.